Anybody know any vectors? Sure, I want an example of a vector. A car moving 70 miles per hour north. That is a vector. Why is it a vector? What's the magnitude? 70 miles an hour, and what's the direction? North. What's another name for that? That's called speeding. Begins with a V. Not vector, though. Another word that begins with V. That's called velocity. What's the difference between velocity and speed?
One's a scalar and
one's a vector. So what's the difference between a scalar and a vector? What's a scalar?
A scalar only has one component.
A scalar only has one component. It only has magnitude. For example, 70 miles per hour. That would be a scalar. That would be speed. But when you say 70 miles per hour north, that's now a velocity. Velocity has two things. It has speed and it has direction. So that's the difference between a scalar and a vector. A scalar is just a number, 20 miles an hour. A vector is 20 miles an hour in a direction. All right. So normally we draw vectors using little arrows. So I might give you this point right here. This is maybe the point 3, 2. And then I might give you this point over here, which is 0, 1. And we would say, let's say we call this point A, and this point is B. I might talk about the vector AB, and we write it that way. We write AB with a little arrow over the top. What would the vector AB look like? Well, that means we start at A and we go to B. So the vector AB would be that vector.
So that little sign on the top is vector?
That little sign on the top, yep. It's kind of like a little arrow. Usually you only draw the top half, because if you draw the bottom half, it gets down into your letter and it gets confusing. So usually you only draw the top half. What about the vector BA? Is that the same vector? No, why not? Because it goes in the opposite direction. The vector BA would be the same magnitude, but it would have opposite direction. What is the magnitude? We usually use this symbol for magnitude. That symbol looks a lot like absolute value, but when you're dealing with vectors, it doesn't mean absolute value. When you're dealing with vectors, that means magnitude, and magnitude is a fancy way of saying the length. So if I gave you that vector AB, how would you figure out how long that vector is? You would use the distance formula. That's correct. So it would be the square root of, how's that distance formula work again?
X1 plus Y1 squared.
X1 plus Y? No, X1 plus X2.
Closer.
X1 minus X2.
You subtract the X numbers. You subtract the X numbers, so I take 3 minus 0, and then I square it.
And then it's a
Plus
Y1 minus Y.
subtract the Y numbers. That's correct. So 2 minus 1
That's squared.
squared.
So would it be a different answer if it was BA?
Would it be a different answer if it was BA? That's a good question. We'll answer that one in a second. What's 3 minus 0? 3. 3 squared is 9. 2 minus 1 squared. So we would have the magnitude of AB is the square root of 10. So to answer Seth's question, what if I asked you to find the magnitude of BA? It would be the same. Why would it be the same?
Because it's the length. Yeah, just opposite.
It's the same length. By common sense, it's the exact same length, right? But if we actually wanted to work out the math, we would have 0 minus 3 squared plus 1 minus 2 squared. But 0 minus 3 is, and when I square negative 3, I still get positive 9. This one's going to give me a 1 still. I'm still going to get square root of 10. So they do have the same length. What if I ask you to find the direction? How do you think we usually represent direction? Do what?
Like an angle?
So normally it's given by an angle. Sometimes we go off north, south, east, and west. But in this case, I think all I would really want is the angle. How would I find the angle?
Find the resultant?
Find what?
Resultant.
The resultant. That's a good word. What's the resultant mean?
It's like, I'll explain it. Like what those two vectors make. I don't know how to explain that.
Usually resultant means if you have two vectors and you're adding them together.
Yeah.
That's not really what I'm looking for here. I'm just looking for the angle. To find the angle, here's what I would do. I would draw a triangle. We always draw triangles in this class, don't we? That's what we always do. I would draw this triangle right here. And this is really the angle I want to find, theta. So what can you tell me about this triangle? How long is this right here?
It's 3.
That one's 3. And how far is this?
2. No.
1.
That one's only 1. Why is that one only 1? Because I started at a height of 1 and I went to a height of 2. That one's 1. Okay, so how could I find the angle? Tangent. So tangent of theta would be 1 over 3. I don't think that's one that shows up on our fancy chart. So I guess the best I could do is I could say theta is tangent inverse of 1/3. And if I wanted to, I could grab my calculator and I could type that in and I could get an approximation. But it's not one of our nice angles, so we would typically just leave it just like that.
So why would it find the angle of the direction?
Because I wanted to. Because what do we do in this class? We draw triangles and we find angles, don't we? It's what we do. We'll have reasons for wanting the angles down the road. For today, we're mostly just finding them, figuring out what they are. Okay, we say two vectors are equivalent if they have the same magnitude and direction. So let's draw this one again here. So there's our vector AB. Can you give me another vector that would be equivalent to that vector AB that I just drew? Can you give me another vector that would have the same length and the same magnitude? BA would have the same length, but it would not have the same direction, would it? So AB and BA would not be equivalent.
If you shifted it down or up or...
Just take the vector and shift it some direction. Which way do you want to shift it? I like down. That sounds like a good idea. All right, so how far down do you want to shift it? So shift it 1 unit. So this becomes the point 0, 0. And take this one and shift it down 1 unit, and that one is 3, 1. And I guess I'll call this one point C and this one point D. And then this vector would be called CD. So there are two vectors. There are two vectors that we would call equivalent. They have the exact same length and they have the exact same direction. How do we know they have the exact same direction? Because all I did is I took this vector and I shifted it down 1 unit. So these two vectors have exactly the same slope. So that would tell us they have exactly the same direction.
What if you were to move it right or left?
What if I were to move it right or left? Sure, I could do that too. You draw the picture here, I guess. Let's make up a new vector. Give me a couple points. Anybody have a point they like a lot? -1, 3 is right here. We'll call this point A. And give me another point. 4, 2. 4, 2 is right here. 4, 2, and that's point B. We connect the dots from A to B, and that's vector AB. Okay, so now give me another vector which would be equivalent. In fact, we're going to be fancy. We're going to go down and over. Okay, so I'm going to start here. How far down do you want me to go? 3 spots. And how far over would you like me to go? 7? No, that's going to be way off my graph. That's too far.
5.
1, that's right. Why 1? Because I like being on the origin. I like the origin. That's a nice point. 0, 0. This is point C. So if I took this point and I moved it down 3 and over 1, to get an equivalent vector, what do I have to do to this point? Do the same thing. Move it down 3, 1, 2, 3, and over 1. So what point would that be? 5, -1. And that's point D. So here would be my vector. This would be vector CD. Well, other than liking the point 0, 0, there was really a better reason for doing that. Generally, when we draw vectors, if I give you a vector, we really prefer that the vector be in what's known as standard form. And standard form means we start at the origin and we end somewhere else. Why is it convenient to start at the origin and then end somewhere else? What if I asked you to find the length of this vector? How would you find the length? I can use a distance formula, and it's easier to use a distance formula. Or what else could I do? Yeah. I draw my triangle. This is 5, this is -1, and I can go ahead and just use the Pythagorean theorem. Makes it easier. And then what if I asked you to find the direction? What if I asked you to find the angle? It's easy. You would use tangent is opposite over adjacent. Can you do that with any vector? Yes, absolutely you can. If I draw a vector anywhere, let's say if I were to draw this vector, I didn't give you the point, so it makes it harder. But if I drew this vector, could you take this vector and move it over and make it start at the origin? Sure, it looks like you would drop it down 1, and then, I don't know, that's maybe 5 to the right. But you would just draw the same vector, down 1, 5 to the right. just draw a parallel vector. Oh, I do it too long. Draw a parallel vector with the same length, but make it start at the origin. And the way you would do it is just see, I got to move this one down 1 and over 5. So I take this one and I move it down 1 and over 5, and you get the same vector. And then it makes it much, much easier to find the magnitude and find the direction. So we do like to write vectors in that way. Questions on that? So you'll see this notation. This vector CD will be written as the vector 5, -1. So when you see a vector written in this form where you have vector equals and you're only given 1 point, what's that telling you about the vector? Starts at the origin and it ends at that point. So you'll see vectors written that way quite often. You'll only be given 1 point. If you're only given 1 point, it simply means you're starting at the origin. Okay? Okay, so number 1 says, sketch the pair of vectors and determine whether they are equivalent. Where I give you AB and I give you CD. All right, so it wants us to first draw a picture. So A is the point 3, 4. 3, 4 is right about there. And B is -2, 2. -2, 2. So there's the vector AB. C is -1, -1. And D is -6, -3. It wants to know, are those two vectors equivalent? Yes? No? Maybe? I could do the distance formula on each one to see if they had the same distance. All right. So the magnitude of AB is the square root of, let's see, I got to subtract my x's. 3 minus -2 squared plus 4 minus 2 squared. 3 minus -2 is 5. 5 squared is 25. 4 minus 2 is 2. 2 squared is 4. 25 and 4 makes 29. And then I do the exact same thing for CD. The length of CD is square root of -1 minus -6 squared plus -1 minus -3 squared. -1 minus -6 is 5. 5 squared is 25. -1 minus -3 is 2. 2 squared is 4. 25 plus 4 is still 29. So they have the same length. So are they equivalent? We don't know yet. Maybe is the right answer at this point. We also need to make sure they have the same direction. There's two ways we could determine if they have the same direction. One would be to find the angle. That would be one way. What would be another way? A way that I think is easier. See if they're parallel. See if they have the same slope. And I think that would be easier. I think it would be easier to find the slopes and see if those are the same. So for AB, the slope is 4 minus 2 over 3 minus -2. That's 2 over 5. I can't be right. What did I do wrong? How come that can't be right?
Because it should be a negative slope.
It should be a negative slope. How come I got a positive slope?
The number is number.
It's a directional thing, isn't it? Because when we find slope, when we always find slope, we're always thinking of going from left to right. But is this vector going from left to right? No, it's going from right to left. So I really should say its slope is negative 2/5. But is it really going to matter? Because what can you tell me about CD? If I get 2/5 again, I'm going to be okay, aren't I? Because it's the same thing. All right, so you got to be careful of that a little bit. That's a little bit confusing. CD, the slope is -1 minus -3 over -1 minus -6. And I do get 2 over 5 again. So are those two vectors equivalent? Yes, because they have the same slope and they have the same magnitude, the same length. All right, well, what are we going to use vectors for? Well, we're going to use them for lots of things. For example, number 2. Number 2 says 2 forces of 50 newtons and 60 newtons act on an object at right angles. What are newtons?
It's not force.
It's a force because it says 2 forces of 50 newtons. That's right, 50 newtons is a unit of force. What else can you tell me about newtons? Anything? It's what?
Units have their vectors. No.
If I were to lift my textbook up, what would that force be? What kind of units would I have on it?
So
It would have potential energy because if I let go, it would fall. It would have potential energy. But what is newtons? What kind of units are we using if we're dealing with newtons? Newtons isn't a direction. Newtons is a force. What kind of units? Feet, miles, inches, pounds. Close though. If you're dealing with newtons, you're working in the metric system.
Yeah.
What's the unit for force if you're dealing in the US system?
Foot-pounds?
Not foot-pounds. Foot-pounds would be a unit of work. Feet times pound would be a unit of work. It's called slugs if you're dealing in the US system. All right. That's not really important. Okay, so we got 2 forces of 50 newtons and 60 newtons act on an object at right angles. Find the magnitude of the result and the angle that it makes with the larger force. All right, so I would draw something like this. We have an object sitting right here at the origin, and we have 60 newtons going in one direction. So that's a vector, 60 newtons, and 50 newtons going in the other direction. Now, if I have a box sitting here and I'm pushing with 60 newtons in that direction and 50 newtons in that direction, which way is the box actually going to move? It's kind of in the middle, except it's going to be more in this direction than it is that direction, isn't it? So the box itself is going to go kind of in that direction. That is called the resultant. So that would be, if you add the 2 vectors together, that's what you get. And I didn't draw this very accurately because what should happen is you should get a parallelogram. In this case, because they're at right angles, you should actually just get a square. Or not a square, you should get a rectangle. I didn't draw it at the right angle there. So what we want to know is we want to know the magnitude. We want to know how far will the box actually move. How will we determine how far the box actually moves? This is 60. This over here is the 50. So we find the hypotenuse. That's exactly right. How would you find the hypotenuse?
Just find
Quadratic formula? No, not the quadratic formula. Pythagorean theorem. R squared is 50 squared plus 60 squared. So R is whatever that number turns out to be. I'm running out of time, so I'll grab my calculator and type that in. And then it says, find the magnitude of the resultant. So there was that word resultant, which means we're adding our two forces together, and the angle that it makes with the larger force. So then we want to find that angle. How would we find that angle? Tangent. So tangent of theta is 50 over 60. So theta is tangent inverse of 50 over 60. And we could grab our calculator, type that up, and get an answer. Okay? Bring the sheet back with you on Monday, and we'll take a look at the rest of the problems on the sheet.